Liam probably is just skipping, and he's probably not going to watch this video. We'll see if he watches the video or not. We've got this. Then, if we want to solve this for the equation, we would integrate both sides. And so, when we integrate dy, what do we get? Just y. And when we integrate the right-hand side, we just use the power rule to integrate. So, we'll have x squared. 2 divided by 2 is 1, so we don't have to write that there. Plus 5x. Gosh. And is that it? Thank you. Testing you there. Make sure you put that plus c. That's going to be really important, especially in this unit. We've got to have the plus c there. So this is a really basic solving a differential equation. As always happens, it gets much harder from here. But that's a very, very basic differential equation. So what we did in that first step is we separated our variables. We put everything with a y over here on the left-hand side and everything that had an x on the right-hand side. And we always have to do that before we can solve, or at least based on the methods we're going to learn in this class. Whenever you go to college, if you are majoring in math or engineering, you will probably have to take differential equations. For some reason, at Meredith College, they did not make us take differential equations. It was like an optional class, and it didn't fit my schedule because it was only offered like fall, even-numbered years or something. So I did not take differential equations, which I wish I had. But anyway, but most of the time, I know for my husband at State, differential equations was a required class for him. He had to have it for engineering. There is a whole class on this. This is just the very beginning part. There's all kinds of other methods you can use to solve first order and second order and whatever order differential equations and stuff. Some stuff I didn't even learn. Some stuff I did learn a little bit about, but you can go much more in depth. Everything we do in this class is going to be a separable differential equation if they're asking us to solve it. So, in order to solve a differential equation using separation of variables, which is the only thing we're going to learn how to do in Calc 1, you must separate variables. All the x's on one side, all the y's on the other. Or they could be different letters. They might be a y and a t or something, but have to separate those variables for that. So, let's look at another example. Here's your next example. Now, the last problem that we did was just basically a power rule problem. And it's been presented to you like that a little bit. And if I had not multiplied both sides by dx at first, you probably still would have got the right answer even without me doing that. This problem is different. Because this problem, our derivative has an x and a y. Okay, so this is like the derivatives that we get whenever we're doing those problems that have x's and y's in them when we take the derivative of something like x squared plus xy minus 3y squared, and you have to do it with the dy dx's and solve there. So this is like the answer to what we get when we do those problems. We are trying to take the answer and go back to the original from this. So first of all, y prime, in this case, equals dy dx. And in my opinion, or the way I teach it anyway, I think it's a lot easier to have dy dx than to put y prime. So I would first switch this to dy dx equals 2x over y. All right, and what we need is we need to have all of the x's on one side and all of the y's on the other side. So that means, for sure, this dx has got to go over to the other side. So on these, just about every time you want to multiply by dx. It can't be in the dx nor the dy can be in the denominator. A variable can be in the denominator, but the dx or the dy cannot. So that would give me dy equals 2x over y dx. And then what do I need to get rid of over here? The y. How do I get rid of that y? Multiply it. So if I multiply by y here, that'll be in numerator and denominator and cancel. I'll multiply by y over here. So I've got... Oh.
Motivation. I'm done.
He did this joke over here. Was...
Yeah. And I said, let's show your mother. I'm good. Let's go ahead and finish.
Oh, yeah. Feel free to motivate him however you need to in whatever way. Yeah. Yeah. He needs a little extra motivation. Yeah. Thank you. Yeah. Yeah. In ways I dread whenever, I mean, he's kind of already over here. In ways I dread whenever he's over here. In other ways, I kind of look forward to it because, you know, keeps me in the loop on what he's up to. All right, so we've got y dy equals 2x dx. Okay, we have separated our variables. dy and dx are in the numerator. They can't be in the denominator, so they're in the numerator. And I've got all the y stuff on one side. I got all the x stuff on the other side. Everybody good there? This is really important. Differential equation, usually there is a differential equation FRQ on the exam. And usually the part where you actually solve the differential equation is worth like 4, sometimes 5 points on that FRQ. It's usually really heavily weighted. And if you do not separate variables, or at least attempt to separate variables and like get, even if you do it incorrectly, you've got all the x's on one side and all the y's on the other. If you don't do that, you will get 0 points out of that. You cannot get any points past that because the only way we know how to solve these is by separating variables. So you must make sure all the y stuff is on one side, all the x stuff is on the other. Typically, I like to put my y's on the left, but they should have made me take differential equations. Yes, but I don't know how.
So, like, if you knew how to do it and you did it on the test, you still get no credit?
If they are a separable differential equation, separating is the easiest way to solve it for sure. The other methods, you would never want to use them because separating would be a lot easier. But on the AP exam, if you do anything that is mathematically correct and you explain it well, you can still get credit even if it's not like a Calc 1 topic. So if you taught yourself, for example, when we get to Unit 8, there are some different methods that can be used to solve some of the problems for Unit 8. They will only give us questions that can be solved using the methods that we are supposed to learn. But if you were to like teach yourself the other methods that there's like a shell method that we don't do. If you taught yourself the shell method and you used it on a problem where it was applicable, as long as you show your work well and it's mathematically correct, you can still get credit. So as long as you are using something mathematically correct. So if you go teach yourself something about different differential equations and use something different that's mathematically correct, you could still get credit. But I'm going to tell you, I'm not, because I didn't have to take differential equations. Who am I kidding? If I had taken differential equations, I probably wouldn't still remember how to do it anyway. But I can't remember exactly like what else there is on those. I know we did do a little bit more with differential equations, maybe in Calc 2, but I don't remember much of it. I've retaught myself all Calc 1, and I once was good at Calc 2. But if you need help on Calc 2 stuff next year, past the stuff that we do in this class, I'm not going to be of much help to you because it's all gone. I would love, I've got my books and I want to like sit down and reteach myself how to do it, but there's no time for things like that. All right, so now we are dealing with y dy equals 2x dx. if we want to solve this, we need to integrate both sides. That'll get rid of our dy's and our dx's, because our goal is to get rid of our dy's and our dx's and just have x's and y's in the problem, and then we have the original equation that would give us this particular differential equation. So both of these sides now are going to require the power rule. The last problem we did also did, but it was just really simple. This was not terrible. You're going to have y to the second, and then you got to divide out front by that new exponent, so 1/2 y to the second, plus, I'm going to put c with a subscript of 1, because on the other side, there's going to be another one. And then I'm going to integrate 2x dx, so that is going to be x squared, and then I'm going to divide out front by that 2, and I'll just get a 1. And I'm going to put a plus c with a subscript of 2 to show that I've got two different c's there. However, I've kind of already talked to you a little bit about this before. C is an unknown quantity, right? We don't know what C is. So if I took this C1 right here and I subtracted it here, I'd have 1/2 y squared equals x squared plus, hello? Yes, you're welcome. Both, they need you to stop by the front office in between classes or something. All right, now if I subtract C2 minus C1, it's an unknown quantity, right? If I have an unknown quantity minus another unknown quantity, what am I going to get? Another unknown quantity, because C2 and C, now if I had C minus C, I would get 0. But these are different unknown quantities. It's possible it's 0, but they might not both be the same number. So that's why I put like the subscripts on those there. So it's still unknown. So I could let C, just regular C, equal C2 minus C1, and I'll just have my regular capital C there. Now, what we're going to find is this happens every single time. If you integrate the left and you integrate the right, you're going to get C's on both sides, and because they're unknown, you can just combine them into one C. So what I've done here with the C2s and C1s, you can do that if you want, but it is not required that you do that. You can just put a plus C on one side for that. However, you do need to make sure you're integrating both sides at the same time if you do it that way. And we'll see some examples of that. Now, sometimes they will ask you to solve that equation for y. Sometimes they will just leave it like it is. With this one, they would do this, 1/2 y squared minus x squared equals c. They might do it that way. It's really just going to depend on what your answer choices look like. Whenever you guys do your assignment, you can look in the back of the book to see what they got, to kind of see how they're leaving it. Because, does anybody know what that's going to look like? We just recently discussed this. It's not a circle. It's one of the conic sections. It's a hyperbola. It's a hyperbola because if it was a circle, it would be x squared plus y squared. They'd have the same coefficient. If it was an ellipse, which is like your oval, right, it would be like 1/2 y squared plus x squared. It'd have to have the same sign there. If you have a minus sign in between them, it's a hyperbola for that. So this is a hyperbola. Usually in a hyperbola, we write the equation like this. We don't try to solve it for y. So I think they might leave it like this. They could do something like this. They could multiply the whole thing by 2 if they didn't want fractions, right? That would be y squared minus 2x squared. What would it equal? C. Why not 2c? It's still unknown, right? 2 times the unknown number is still just another unknown number. You could write 2c if you wanted, but a lot of times that c just kind of like absorbs everything that's done to it. You could, what I would probably do though, is like, I did this first time to explain why there's only one C. Usually I just put one C. You don't have to put it on both sides. And we'll see that on the next problem. All right, let's try another one. Actually, no. This one is not one you're solving. I want to know whether these are separable or not. Okay? So you don't necessarily have to write all those directions if you want. But I want to know if these can be separated or not. Meaning, can we get all the T's on one side and all the Y's on the other for this? All right. What do you guys think about A? Can we separate those? Luke says no. Anybody agree, disagree? What do you think about B? Can you separate B? Or C? Have any ideas? Or do we need to go through them all? Let's try. Let's try to separate A. Okay? So we're going to try. So that means I need to get all of the T's on one side, all the Y's on the other. Right? So, first off, if I'm going to do that, I cannot keep that DT in the bottom. So I would probably start off every one of these by multiplying by DT. So, like, let's just go ahead and do all of them. Alright, so I've got dy equals y plus t dt. That y is in my way. Can I get rid of it? Okay. Could I subtract it? Why not? Right. So if I wanted to try to subtract it, I'd have to distribute that dt, right? So I'd have dy equals y dt plus t dt. And I could subtract it now, but there's a dt hook to it, right? Which means I got dt on that side. So then I would have dy minus y dt equals t dt. Is there any way to get rid of that dt? What if I divided it? Could I divide it? I could divide it, but if I divide it, what else has to be divided? Dy. And then I've got dy dt minus y equals t. And then I'm about to get back to where I started in the first place, right? So I'm not getting anywhere with that. This one will not separate. That's a no. Okay. In general, when you see that your two variables are added or subtracted, there's a decent chance it won't separate for that. Now, they are not going to give you one that will not separate and ask you to solve it. They might give you one that's not separable and ask you to do a slope field, because you can do a slope field for things that won't separate. They might ask you questions, like ask you to write an equation of a tangent line or something about the solution, but they won't ask you to find the solution on one like A. Okay? What about B? We are sitting here. We got dy equals ty over t plus 1 times dt. We got that y over there on the right side. Can I get rid of it? If I wanted to get rid of it, what would I have to try? Do I have to keep the t with the y? I don't. So if I multiply this side by 1 over y, right, then, and this is all multiplied, right? I got 1 times t times y on the top. I could put like parentheses here, right? This is multiplied as well. I could cancel that y right there, which means I could multiply by 1 over y over here as well, and I would have 1 over y dy equals t over t plus 1 dt. That will separate. That's a yes. Okay, and we'll learn how to solve that, but we're not quite there on one that hard yet. All right, this one we're sitting at dy equals e to the t plus y dt. Will that one separate? Honestly, when I've left this one in the notes. This one, I've used these same notes for several years now. And when I first made these notes, I had no for that one. I thought it was no. Because I got that plus t plus y in the exponent, which normally if we got addition, we're not going to be able to separate that. But I was wrong. This one will separate. E to the t plus y can be rewritten. How could I rewrite that? Nope. Not e to the t plus e to the y. Times e to the t times e to the y. Because if I have something like x squared times x to the third, what do I do with the exponents? I add them together. I'd have x to the 2 plus 3. Normally we wouldn't never write it that way because we do 2 plus 3 in our head and we get x to the fifth. But if we were doing this, e to the t times e to the y, we would have to write e to the t plus y. So if I write it like that, e to the t times e to the y dt. Now I've got all that stuff multiplied together. Can I get rid of that e to the y? Divide it off. E to the y. Divide by e to the y. You got dy over e to the y equals e to the t dt. All of your x's are on, all your y's are on one side, all your t's are on the other. You also might see this written as like e to the negative y dy equals e to the t dt. That makes it easier for the next step. So that one's a yes. It will separate. Although originally that question was a multiple choice question, there was only supposed to be one answer until I realized that it would in fact separate. I probably taught a couple classes that wrong before I realized what was up. All right. Let's look at example 4. All right, so we got dy over dt equals y squared e to the negative t. We need to separate variables first thing. You cannot solve this until variables are separated. What's the first thing I should do? Pretty much every time. Multiply by dt. You cannot solve with the dt's or the dy's in the denominator, so we need to multiply by dt. So we got dy equals y squared e to the negative t dt. Okay, what do I need to do next? I can't, because everything here is multiplied together, right? Like if it was y squared plus e to the negative t, no, I would not be able to do that. It would not be separable and I couldn't do the problem. But everything's multiplied, so I can just divide by y squared. So that gives me dy over y squared. I would prefer not to have a denominator there. How could I write that so I wouldn't have a denominator? Y to the negative 2 dy equals e to the negative t dt. I really like the differential equations unit because it embeds review in it automatically, because the next step is to integrate both sides. So not only are we learning how to solve differential equations, you're integrating each side of this, which makes you review all those rules you knew for integration. So on the left side with our y's, we're just going to have to do the power rule. What are we going to have to do on the right side? It's not called the chain rule whenever we're integrating, but it's kind of how we deal with things that chain rules for taking derivatives. U to U substitution is how we deal with like the reverse of chain rule. So I'm going to work on this right side first. I may not integrate that left side yet, even though it's very simple, because it's really important on these, especially for response problems. Your work is going to be wrong if you don't integrate both things at the same time. In order for us to put just 1 plus c on the same time, we want to make sure we don't integrate until we're ready to integrate both of them at the same time. So sometimes that means you might hold on to something simple for a little while till you get the other more difficult side ready to integrate. So what is the u for this? Negative t. So du would be, what's the derivative of t? Negative dt. Which we have the dt. We need it to be negative. And in order to put the negative on the inside, what have we got to do on the outside? A negative 1 there as well. So I'm not going to integrate the left just yet. I'm going to do y to the negative 2 dy equals negative integral of e to the, this stuff right here is my u. This stuff right here is my du. So I've just got e to the u du. Even though I could have integrated that left side, I'm waiting until I integrate both sides at the same time. So now I'm ready to integrate both sides. If I integrate the left, that's just a power rule. I'm going to increase my exponent by 1, which is going to make it negative 1. And then I divide out front by that negative 1, just giving me a negative out there. This could have a plus c with it, but I'm just going to put it on the end on the other side. So I'm not going to put the plus c right there. You could if you wanted to. You needed a c1, c2 thing, but you don't have to. And then what is the integral of e to the u? E to the u. So I got negative e to the u, and I'm going to put a plus c here. Now, if you want to, for this, you could have in that step, went ahead and put your u back in. I've got negative y to the negative 1 equals negative e to the negative t plus c. Now, at this point, you have solved the differential equation. However, sometimes they want that differential equation to be solved for y. Usually, if they do that, they'll say, how is it they word it? They do like, let y equal something over here. I need to go look at the problem for that. But sometimes they want this solved for y. It just depends on what they give you for instructions. I'll show you some more problems as we go along. But let's say they do want us to solve for y on this. I've got negative y to the negative 1. To solve for that, what do you guys think we should do? We're trying to get that y by itself. Okay, multiply by negative 1. That'll get rid of the negative. So that will give me y to the negative 1 equals positive e to the negative t plus c. Are some of you thinking that I messed up? Did I mess up? Okay. Would it be okay to put minus C? Do you have to put minus C? You don't, because C is an unknown quantity. So C could be positive or negative already. So if you want to leave it a plus C, it's fine. If you put a minus C, it's still correct. It's okay for that. But C kind of absorbs pretty much everything that happens to it, other than, we're going to see here in a minute, sometimes it's got to go like to a denominator, but as far as multiplying, adding, subtracting, dividing, that sort of stuff, it just pretty much stays like it is. Or put a minus C. Either one's fine. All right, we're still not done. How would we do this? How do we get rid of a negative 1 exponent? You can. So we can make this 1 over y equals e to the negative t plus c. All right, what do we got to do now? Yeah, we can't solve for that y while it's in the bottom, right? So we got to multiply by y. This feels like it's making it worse, doesn't it? 1 equals y times e to the negative t plus c. Make sure you keep parentheses around that, because that whole side is multiplied by y. And now divide by e to the negative t plus c. Now, the plus c does end up in your denominator here, so y would equal 1 over e to the negative t plus c. If they ask you to solve for y, that's your answer. If they don't ask you to solve for y, you could have left it right here. It just depends on what your direction is asking for. Let me show you one more option right here. When we had it right here, y to the negative 1 equals e to the negative t plus c. One thing that can make you a really good mathematician is knowing multiple ways to solve the same problem. Here's another option. Raise that to the negative 1 power. Raise this side to the negative 1 power, right? When we do power to power, what do we do with the exponents? We multiply the exponents. Like if I've got x squared to the third, that's x to the 6th. If I multiply my exponents here, what do I get? 1. So that's just y. And I've got e to the negative t plus c to the negative 1, which can be written 1 over e to the negative t plus c. So that's a little faster, a little bit. But definitely do whatever you're most comfortable with that. There. Okay, questions? All right, I got one more I want us to do. This one looks bad, doesn't it? So bad. We're going to feel so smart once we do this one. All right, the first thing I would do, and you might even want to do this as you write down the problem, I'd change this y prime to a dy dx. It is much easier to separate variables using dy dx here. In fact, I think I've seen them done without the dy dx, but I can't even really remember what people do. Okay, we can't do anything till we've separated variables. Normally I've been telling you like to multiply by that denominator first, but I don't know if that's a good idea here. What would you guys do first? Subtract 3xy, because we need it on the other side. So we got 1 plus x squared dy dx equals negative 3xy. All right, what would you do now? Yeah, let's get that. Let's get that over here on this side because it's an x and it needs to be on that right side. And it's okay to have variables in the denominator. We just don't want our dy or our dx to be in the denominator. So dy over dx equals negative 3xy over 1 plus x squared. All right? We're getting there. We're actually pretty close now. Multiply by what? Yes, we want to do that. I would say maybe I would go ahead. There's something I, as a personal preference, would do first before I did that. Or you could do it at the same time. I would get that dx over here. Which really, if you want to do it at the same time, the y needs to come over here. So I'd multiply by 1 over y. And 1 over y right here. So I've got 1 over y dy equals negative 3x, because that y cancels with that y, over 1 plus x squared dx. Are we good? Everything separated now? dy's and dx's are in the numerator. It's okay if you have variables in the denominator, but your dy and dx can't be. I mean, I realize I don't really have them written in the numerator, but if we put them over 1, they're in the numerator, right? They're not in the denominator. So we're ready to integrate now. So that was a lot of work just to get, we haven't even started to solve yet. We've just separated. And that part, if you don't do that part correctly, then it's no good from there. Now, on the last problem, I wanted to use negative exponents. I didn't do that over here on the left. Why? If I've got y to the negative 1 and I try to integrate it, I increase the exponent by 1, which makes it 0, and then I have to divide out front by 0. Does that work? No. What was the integral of 1 over y? It was natural log, right? Whenever you try this with exponents, it doesn't work. That should remind you, oh yeah, this wasn't what I was supposed to do anyway. If I've just got 1 over y, I get natural log of y. Oh wait, hold on. I'm getting ahead of myself. Should I do this yet? Is the right side an easy integral? It is not. What am I going to have to do on the right side? I'm going to have to do some u to u. So let's hold up here because I have to integrate at the same time. So let's just leave this 1 over y dy. Actually, I'm probably going to need some more space right there. Let's just hold off on that. All right. What's my u over here? 1 plus x squared. What's my du? 2x dx. I do not have a 2x. I've got a negative 3x. What could I do with this negative 3 right here? I could multiply by negative 2/3. Or I could just pull it out front. If you want to think of it. Either way you want to think of it will work fine there. And then if I pull that out front, I still have to multiply by a 2 on the inside and a 1/2 on the outside, which is multiplying by a negative 3/2, which also works. So it just depends on which way you want to think about it. There. So I'm not going to integrate this yet. 1 over y dy equals, and then I've got, this is going to be negative 3/2 integral of, let's make sure we know where things are coming from. This part right here is my u. This 2x dx, that's my du. So if I replace those things, I've got 1 over u du. Everybody okay here? All right, so on the left side, I got ahead of myself a minute ago. That's going to be natural log of the absolute value of y. And I could put a plus c there, but I'm just going to wait and put it on the other side. Over here, I'm going to get negative 3/2 natural log absolute value of u. And I'm going to put my plus c over here. And what was my u? 1 plus x squared, so let's put that back in. Natural log absolute value of y equals -3/2 natural log of... Do I need absolute value bars if I'm plugging in 1 plus x squared? Is that ever going to be negative? It is not. So 1 plus x squared. A lot of times you'll see them drop it. If you keep them, it's fine because it's still correct. All right, so this is solved. This is, if all they ask you to do is solve the differential equation, this is done. They might ask you to solve for y.
Yeah.
They would.
Yeah.
They would. They would do it. Now, this is a problem that if Coach Wood was still here and he walked by, what would he yell? Drop the logs. But can we drop the logs right now? We cannot. And actually, we're going to see, we kind of can't drop the logs here. But this right here, what can I do with it? Log properties. Oh gosh, we're doing pre-cal right now. It's a power. Okay? So we got natural log, absolute value of y equals natural log of 1 plus x squared to the -3/2 power plus c. And then it feels like you should be able to drop the logs right here, but can you? What's preventing you from being able to just drop the logs? The c, right? So what you're doing is you're doing e to the power on the left side, which does just drop that log. Then you're doing e to the power on the right side, which does not drop the log because of that plus c on the end. If the c wasn't there, then they would cancel, but the c is there, so we can't just pretend like it's not there. So on this side, we are going to have absolute value of y equals. Over here, we have e to the natural log of 1 plus x squared -3/2 plus c. All of this is in the exponent. Now, those absolute value bars give us some issues, although there's going to be a way we can get rid of that through what I'm going to do next. But the y is pretty much by itself, right? This is a mess over here, okay? But on that last problem, that other problem we did, I had the e to the x plus t, correct? And I broke it down into the e to the x times e to the t, okay? I'm going to do something similar over here because I got this big mess that is multiplied together, and I'm getting close on time. And I've got that c. So I'm going to write it like this. E to the natural log of 1 plus x squared to the -3/2 times e to the c. Now, over here, the e's still going to be there. Well, kind of. We'll talk about that in a second. What about now for the e and natural log here? They can cancel now. So I've got y equals 1 plus x squared to the -3/2. Now, let's talk a little bit about e to the c. E to an unknown value equals an unknown value. So I could just write that as times c, because c is like invincible. Nothing happens to it. And normally, we will see it written right here, c times 1 plus x squared -3/2, like this. Good question. Absolute value means I could have a positive or a negative there, right? So it means I could have a positive or negative there. Is c positive or negative? We don't know. It could be either one. It takes care of those absolute value bars.
So in theory, y equals c.
No, you have to have the other stuff there because C's just a constant. All right. All right. 382, 1 through 8. I want you to try those over the long weekend for me. Most of them are going to be like the easier ones. You might have a couple that are like this hard one, which we did. We're going to do more of that next week. So don't think that's all we will do. We're going to do a lot more of that because usually kids are